Hello and welcome to another one of D's ADD videos. Today we're going to be looking at substitution versus elimination, 1 versus 2. We're going to be looking at the big picture. A lot of people spend so much time on the individual details of these reactions that they lose sight of how to determine which one is which for what situation. So don't get too caught up in the details and lose sight of the big picture. So we're going to start off by looking at what the difference in the two bonds are, or reactions. So we're going to have a look at a substitution. Basically, a substitution will be something like this, in which you have a it's a little big a compound Okay, so I'm just going to use this as an example. We can either have a substitution type of reaction in which we go from this to this, so basically this leaving group, which we will discuss what leaving groups are in another video, is replaced by this compound. That's a substitution reaction. Now for an elimination reaction, what would happen is we would take that same scenario and create a double bond. And this is usually done by abstracting a hydrogen, leaving the electrons behind in order to form a pi bond. So the leaving group, again, I'm going to make Br. And then when this thing leaves now in an elimination reaction, what happens is you take away an adjacent hydrogen, so we have a few choices here. I'm just going to highlight a few of them. We have a hydrogen that's right here, or we have a hydrogen that's adjacent to the leaving group carbon that's right here. Okay, so you can abstract any one of those hydrogens, and depending on which ones you abstract, you're going to end up with a structure that has an alkene or a double bond in it. So you would end up with something like CH3 and then H and CH3. Okay, so in this case, the thing that was replaced, it was still the leaving group, but it was replaced, instead of by a compound, it was replaced with this double bond right here. Okay, so that's the basic difference between substitution and elimination. Now let's look at 1 versus 2. What is 1 versus 2? So change back to black, and 1. The 1 reactions, they use a weak to moderate nucleophile. Or it could be a base, depending on whether it's an elimination or a substitution. So, or a base. And we know it's moderate because you'll see an alcohol, for instance. Okay, sometimes you'll see you know, methanol or ethanol or something like that. These are weak attackers, so they're going to undergo what's called a solvolysis reaction. And solvolysis reaction is basically when the solvent does the work. So in this case, the solvent is the attacker, is the nucleophile, is the base. Okay, so they're either the base or the nucleophile. So if we attack the carbon itself, it's called a nucleophile. But if you abstract a hydrogen, it's acting as a base. So it can be the same thing and do both. So that's why you have to know what conditions apply to what. Okay. Solvolysis, let's see what else. It's a two-step reaction for these things. Not sure why I underlined that. Oop, didn't mean to do that either. So, two-step reactions. The first step is form your carbocation. And the carbocation ion stability is increasing with the number of carbons. Oops, wrong direction. Increasing with the number of carbons attached to it. And this is due to what's called the inductive effect. Each carbon shares the burden of the plus charge. They work as a team. Inductive effect. Alright, so after you form the carbocation, then what happens? Well, then we get the reaction takes place. So either it's in substitution or elimination. Also, because the reaction is an E1, the kinetics are only dependent on your electrophile, the thing you're attacking. So, E for electrophile. And if you remember what an electrophile is, or don't remember, that example that I showed you earlier, this bromine right here is very electronegative compared to that carbon. So what happens is it pulls the electron density around the bromine and makes this partially negative. As a result, this carbon becomes partially positive and really wants electrons at that point. So therefore it's called an electrophile. Okay? Alright, so that's a rate. I believe I've covered everything for the ones. Two-step reaction, weak to moderate nucleophile. Now let's look at the two reactions. So the two reactions are going to have, I'll do that in blue so you don't know what's different there. We're going to have a concerted reaction, and we're going to form a transition state. So basically what happens is the moment you form that bond, you start to break the bond with the leaving group. The moment the bond is starting to form with the electrophile. So basically what's happening is as soon as my attacker comes in, whatever the attacker is, nucleophile, then it starts to break the bond with your leaving group. In our case it was the bromine. And that's called a transition state, and it's represented there, the double dagger in the brackets. Alright, almost done. So we know that we need a strong attacker for these. So strong attacker is usually in the form of RO-, so methoxide anion there. Don't be thrown off if you see the actual alcohol. It might be written in the form like this, where it's got the alkoxide ion on top, but then it's actually got the alcohol on bottom as well. This is still considered to be strong because of the presence of this thing right here. Okay, so this thing right here, when it ionizes, that charge pops up and the sodium disappears, and you get that charge right there, that minus sign. Okay, that's a very strong attacker. Will force a 2 reaction. And we'll discuss later whether it will go to E1 or E2. I mean, sorry, SN2 or E2. But for now, a concerted reaction, strong attacker. Can't really go a hierarchy here because SN2 is methyl 1,2. I'll write it down. So the SN2, a little big there, is methyl is greater than primary. It doesn't like what's called steric hindrance. It wants to avoid bumping into other things. Whereas E2 is the exact opposite. It's just like everybody else. It's tertiary, secondary, primary. So you got to know what you're going to be doing, what takes you down that road. So know strong versus weak to moderate. Okay. Know also the difference in the basic reactions. Are we replacing an element with another group, or are we creating a double bond by removing a hydrogen? Alright, so that's basically a rundown of the big picture. I don't want to go too much further into it. Make sure you practice. Learn to see not only the beauty of one tree, but appreciate the beauty of the entire forest. A little wisdom for you. So thank you and have a nice day.